Imagine you wake up one morning, check your phone, and nothing loads. GPS fails worldwide. Power grids flicker. Satellites begin dropping offline one by one. Airlines urgently reroute midair. Astronauts aboard the ISS stare in disbelief as their radiation sensors spike off the charts. Within minutes, global space agencies confirm the unthinkable. Earth's magnetic field, our invisible protective shield, has collapsed completely. No warning, no gradual weakening. Just gone. Suddenly, Earth is naked in space. Charged particles from the sun, normally deflected by our magnetic field, now slam directly into the atmosphere at nearly the speed of light. The auroras ignite instantly, so bright they overpower daylight in some regions. But this is not a beautiful light show. It's the opening signal of planetary chaos. Radiation storms sweep across the planet's upper atmosphere, frying satellites like circuitry drowned in acid. Astronauts rush into shielded modules, counting the seconds between solar bursts. Planes flying over the poles report communication blackouts and are forced to descend immediately. On the ground, people feel something strange, an electric taste in the air. Power transformers begin overheating as geomagnetic currents surge through them. Emergency broadcasts interrupt every channel, warning that more solar activity is inbound and protective protocols are failing without the magnetosphere. Scientists have always warned that the magnetic field is one of the most essential features making Earth habitable, but few ever imagined what would happen if it vanished in an instant. Now the world is about to find out. Before we continue into the full disaster unfolding across the planet, please like this video, subscribe to the channel, and comment your question below. Earth's magnetic field isn't just a scientific curiosity. It's the silent guardian that has protected our planet for billions of years. Generated deep inside the molten outer core, this magnetic shield deflects most of the harmful solar wind and cosmic radiation that constantly bombard our world. Without it, Earth's atmosphere would be exposed to the same relentless punishment that stripped Mars of its once thick air. So what if today, at this exact moment, that protective shield simply switched off? This video explores a dramatic but scientifically grounded thought experiment. A sudden total collapse of Earth's magnetic field. Not a weakening over centuries, not a slow reversal and abrupt disappearance. A moment where humanity goes from shielded to defenseless in a single instant. Why is this scenario so fascinating? Because it forces us to understand how deeply we rely on something we never see, never feel, and rarely consider. It reveals how vulnerable our technology truly is, how volatile the sun can be, and how quickly Earth's atmosphere could change under direct solar assault. In the next sections, we'll break this scenario down step by step. First, we'll examine the immediate scientific consequences in the upper atmosphere and near Earth space. Then we'll follow the chain reaction across the environment, climate, technology, and eventually long-term survival. Prepare for a journey into a world where the invisible shield that makes life possible disappears, leaving us to face the raw cosmos alone. Immediate, atmospheric, and space consequences. The moment Earth's magnetic field shuts off, the first battlefield is not the ground, it's the space surrounding our planet. The magnetosphere, normally shaped like a giant protective bubble, collapses instantly. Without it, the solar wind no longer flows around Earth. It slams directly into the upper atmosphere like a high-speed cosmic tsunami. Within minutes, the ionosphere becomes violently unstable. This is the charged layer of the atmosphere that allows radio communication, GPS timing, and satellite signals to function. But now, solar radiation is hitting it at full intensity. Electrons detach from atoms in massive waves, creating a turbulent, chaotic plasma. Radio waves scatter unpredictably. Long-range communication becomes nearly impossible. GPS networks go blind. Navigation systems that rely on precise timing drift into error. Meanwhile, satellites begin to fail across every orbital band. The radiation that normally gets deflected spirals straight into them. Solar panels degrade in hours instead of years. Sensitive electronics short-circuit under particle bombardment. Imagine thousands of satellites, weather monitors, internet constellations, military systems going dark. The world's technological infrastructure enters its first stage of collapse. But the most dramatic visual change appears in the skies. Auroras erupt across the entire globe, not just near the poles. Curtains of neon green, red, purple, and blue shimmer over deserts, oceans, and cities near the equator. To the untrained eye, it might look beautiful. To scientists, it's a sign of disaster. Evidence that energetic solar particles are penetrating deep into the atmosphere. Astronauts face perhaps the worst risk of all. Without the magnetic field's protection, radiation levels around Earth multiply. Anyone aboard the ISS or other spacecraft receives a potentially lethal dose within hours. Emergency evacuation procedures begin immediately, but not everyone will make it back before conditions worsen. The upper atmosphere itself starts heating and expanding from the incoming solar energy. This creates extra drag on satellites still in orbit, pulling them downward faster. Space becomes a chaotic debris field. This is only the beginning. Environmental impacts and cascading planetary effects. As the chaos in space intensifies, Earth's surface begins to feel the second wave of consequences. Without the magnetic field deflecting the solar wind, the upper atmosphere is now under constant erosion. Streams of charged particles directly strip away atoms from the exosphere, the highest, thinnest layer of air. This process, called sputtering, is the same mechanism that helped transform Mars from a warm, wet world into a frozen desert. While Earth's atmosphere is far thicker and more gravity bound than Mars, the loss begins immediately. Oxygen and hydrogen particles accelerate into space. At first, the loss is tiny and perceptible to everyday life, but the process has started, and it will continue for as long as the magnetic field remains absent. Closer to the ground, geomagnetic storms trigger massive electrical disturbances. Power grids experience surges far beyond their design. Transformers heat up, fail, or explode. Entire regions face blackouts, some lasting hours, others days. Nations with northern or southern latitudes, Canada, Russia, Finland, Norway, Chile, New Zealand, are hit hardest because solar particles penetrate deeper where the field is weakest. Commercial aviation grinds to a halt. High altitude flights are suddenly dangerous due to intensified radiation. Airlines reroute aircraft to lower altitudes, burning more fuel and causing global travel disruption. Over polar routes, flights are canceled entirely. Communication interference makes them too risky. The ozone layer begins weakening as energetic particles break apart molecular oxygen. This allows higher levels of ultraviolet radiation to reach the surface. Sunburns occur faster. Skin cancer risks skyrocket. Crops, especially those sensitive to UV exposure, start showing signs of stress. In some regions, plant leaves bleach under excessive radiation. Animals that rely on geomagnetic navigation, whales, birds, turtles, bees, become disoriented. Migration paths break down. Entire ecosystems begin slipping into confusion as species lose their sense of direction. Meanwhile, extreme weather events begin fluctuating unpredictably. The heated upper atmosphere disrupts jet streams, altering storm paths and seasonal cycles. Weather models lose accuracy, making forecasting unreliable. Humanity is only days into the event, and yet the world is already becoming unfamiliar, unstable, and exposed. Long-term outcomes: atmospheric loss, climate shift, and human survival. Weeks turn into months, and the consequences of a magnetically unprotected Earth begin shifting from disruptive to transformative. The slow erosion of the atmosphere accelerates during periods of heightened solar activity. Every solar flare blasts away a little more of the exosphere. While it would take thousands of years for Earth to lose a catastrophic amount of air, the trend is unmistakable. Earth is now bleeding into space. Over decades, this constant atmospheric stripping leads to subtle but measurable drops in pressure. Air density slowly decreases, weakening the greenhouse effect. Global temperatures begin to fall, not gradually, but in uneven pulses triggered by solar cycles. Winters stretch longer, summers shrink. Some regions experience sudden cold snaps as the climate destabilizes without a consistent upper atmospheric structure. The ozone layer continues thinning. Even on cloudy days, ultraviolet radiation becomes harsh enough to require protective gear in many regions. Outdoor labor declines. Agriculture shifts indoors or into UV-shielded greenhouses. Nations begin rationing food. Crop yields shrink as sunlight becomes both more inconsistent and more dangerous. But one of the most unexpected consequences is the growing layer of artificial debris. Without the magnetic field and with the upper atmosphere expanded, satellite drag becomes unpredictable. Old satellites fail, fall, and fragment. Space becomes littered with thousands of uncontrolled metal shards. Launching new spacecraft becomes incredibly risky. Humanity slowly loses access to orbit, the very vantage point that once made modern civilization possible. Ecosystems face mounting collapse. Migratory species decline drastically. Pollinators weaken. Marine navigation for whales and dolphins becomes chaotic, causing mass stranding events. Coral reefs, already stressed by climate change, are hit with intense UV radiation that bleaches them at unprecedented rates. By the 50-year mark, the transformation is undeniable. Earth has begun a slow march toward becoming more like a colder, more hostile version of early Mars, still habitable, but far more dangerous. Human survival becomes a question of technology. Underground habitats, radiation shelters, and atmospheric research become global priorities. Nations collaborate not out of goodwill, but necessity. The first discussions begin on whether humanity should attempt something once unthinkable, artificially recreating a planetary magnetic field. The future becomes a race against the sun. In this hypothetical but scientifically grounded scenario, Earth's magnetic field disappears in an instant, and our world is thrown into chaos. The first impacts strike the upper atmosphere, where solar radiation destabilizes communication, destroys satellites, and exposes astronauts to dangerous levels of cosmic energy. Auroras ignite across the entire globe, not as a beautiful spectacle, but as a warning sign of a planet suddenly unshielded. As days pass, the collapse spreads downward. Power grids overload, navigation fails, and aviation becomes dangerous. Animals lose their migratory instincts. The ozone layer grows thinner, allowing severe ultraviolet radiation to reach the surface. Humans must adjust to a world where outdoor exposure becomes a calculated risk. Over decades, long term consequences reshape the planet itself. Earth slowly loses its upper atmosphere. Climate patterns destabilize, turning seasons unpredictable. Crops struggle under erratic weather and harsh UV radiation. Satellites fall from orbit and fragment, turning space into a hazardous debris field. Humanity faces the daunting challenge of surviving without the natural shield that once made Earth uniquely livable. Yet this scenario also reveals something profound. Life on Earth, and especially human civilization, depends on invisible forces working silently beneath our feet. The magnetic field is a reminder that our planet is not just a home, but a delicate system of interlocking protection. If the shield vanished tomorrow, our future would become a race against cosmic forces we can neither negotiate with nor ignore. And it leaves us with one haunting question. If Earth's magnetic field ever truly failed, could we rebuild our world before space takes it from us?